This is the final exam review for special problems in animation. Some useful keyboard shortcuts that we've used during the semester. Remember, if you have a layer selected and you press U, it will reveal all the keyframes that you have created for that current layer. Or if no layer is selected and you have the timeline selected, it will reveal all the keyframes for the current comp that is open in the timeline. If you have a 3D layer selected and you press AA quickly, the material options for the 3D layer or the light options for a light layer will be displayed, and you can select if you want it to cast shadows, for example, or if you want it to be extruded. When you have a sound layer and you have the sound layer selected and you press LL, it will show you the audio waveform, so you can see where the sound gets louder and quieter for that particular layer. Anytime you are using any other tool except the text tool, don't use it with the text tool, but if you press V, you will get the selection tool that will become the current tool. When you have a layer and you select it and you press P, it will show the position transforms, the X, Y, and if it's 3D, the Z values that you can manipulate for position. The T will reveal the opacity. Remember, it's not the O, it's the T for opacity or transparency, and that shows the opacity transforms for the current layer. So you can make it become invisible by taking it to 0%, or you can make it fully visible by taking it to 100%. The R reveals the rotation transforms for the current layer. So you can rotate it left or right or circular. And if you use the 3D, the Z will rotate it like a pinwheel as you're looking at it. The S reveals the scale transformations for the current layer, and while the chain link is on, it will maintain the proportions, but if you click on the chain link, you can change the height independent of the width, or the width independent of the height. Some keyboard shortcuts that you'll find in every Adobe program. Command Z, almost every program in existence uses that for undo, and it will undo the previous action. Command A will select everything, and Command S will save your file. After Effects 3D lights. Remember, there are 4 types of lights available in After Effects, and you choose them depending on what kind of effect or what kind of lighting you want in your space. Ambient light will not cast shadows. It's a fill light. It has no definite direction. It sort of bathes everything in just a same general light. A spotlight casts shadows. So it will cast the shadow behind the object as long as there's a setback to the background layer. It has a definite direction and a focus. And remember, it's shaped sort of like a triangle coming out. It's like a cone shape. A point light will cast shadows, and it fills from the center. It has a source, which is this, like a light bulb, and the light rays come out from that light bulb all around it, like a big fan or like an umbrella shape. A parallel light will cast shadows. The light is even, so it evenly casts shadows. It has a definite direction, but no focus. And all of the shadows will continue in the same direction. They don't spread out like a spotlight shadow does. So here's what an ambient light would look like. I took just a screen grab of an ambient light on just a plain blue background. You see there's no shadow, no variation in the light. It's just completely lit at the same level. Then a spotlight. It has a center. It has a specific source and direction. The light has a cone shape. You can have a soft or a sharp edge. And if the object goes behind the light, So if it comes closer to the viewer, it will be dark. So the object can be in front of the viewer, but the light can be behind that. So it wouldn't be lit by the light. A point light has a definite position. It's like an incandescent light bulb. The light is emitted outward in a complete circle. It will cast shadows, and you can see there's the fall off. So it gets grayer and grayer out from the center that's the brighter. And it's like a light bulb. It's like having a light bulb just sitting there. Parallel light, once again, it looks almost like the ambient light, except if there was something standing in front of it, or in front of you, it would be casting a shadow. And you can see down on the left-hand side at the bottom, go underneath the black, and you see that is the depiction of a parallel light. It's showing that the arrows or the light rays are going straight in the same direction without spreading out. 3D space. So you have X, which is the horizontal, Y, which is the vertical, and Z, which is the space coming towards the viewer and away from the viewer. Okay, so it's the Cartesian, named after Descartes, Cartesian coordinate system, referring to the X, Y, and Z graph used to place objects in the 3D computer graphics world. And if you read the Wikipedia entry, it says, if a diagram, or it did when I got the, who knows, someone may have changed the wording, but it's the same thing. If a diagram, a 3D projection, or 2D perspective drawing shows the X and Y axis horizontally and vertically, respectively, so X horizontal, Y vertical, then the Z-axis would be shown pointing out of the page toward the viewer or camera. In such a 2D diagram of a 3D coordinate system, the X-axis would appear as a line or ray pointing down and to the left or down and to the right, depending on the presumed viewer or camera perspective. In other words, it's going to depend on whether you're to the left or the right of where it begins, whether it's going to point left or right. So in Z-space, in the 3D world of After Effects, the Z-axis is oriented away from the viewer, and that means the negative Z number will bring an object closer to the viewer, and a positive number will be further away from the viewer. So 3D space, X, Y, and Z coordinates, and this is a screen grab from an earlier project I did, 3D, and of course it had to be a low resolution or it wouldn't actually display for the screen at the time. So it's kind of chunky looking, but you can see the red, green, and blue arrows that After Effects uses to show you where the axes are. So you see that the blue axis is the X-axis. The Y-axis is the green axis. And the red axis is the Z-axis. So the X-axis points to the left and right. The middle of the screen is at 640 on the ruler, counted in pixels. 0 is on the left-hand side. The right-hand side has 1280. The Y-axis points up and down. The middle of the screen is at 360 on the ruler. The top of the screen is 0. The bottom of the screen is 720. The Z-axis points away from the viewer. The center of the screen is at 0. Negative numbers are closer to the viewer. Positive numbers are further away from the viewer. And if you remember, the lights, when you first put them into your space, the lights default to negative 444.4 on the Z-space. After Effects 3D transforms X, Y, and Z coordinates. The X-axis is the red arrow axis. It's the horizontal axis. Numbers on the rulers start at the left at 0 and move to 1280 on the right. The Y-axis is the green arrow axis, is the vertical axis, and numbers start at the top at 0 and move to 720 at the bottom. The z-axis, the blue arrow axis, is the depth in space axis. Numbers start at 0 in the mid-plane of the screen and grow positively as you move away from the viewer, and negatively as you move toward the viewer. And here you remember this is the position, and these are the different position settings, and you can see the original position for this JPEG is at 640 in the middle in the x-axis, the red arrow axis. It moves objects to either side of the stage. The middle number is the y number. The y-axis is the green arrow axis. You can use this coordinate to move things up or down on the stage. And the z-axis, the blue arrow axis, this is the third number. Use this arrow to move objects in front of or behind other objects, or to position the lights or cameras to show best what you want to show in your composition. So in 3D space, X, Y, and Z rotations, a rotation of 90 degrees around the x-axis will allow you to lay a flat plane down like a floor or a ceiling, and using position on the y, you can move it up or down. A rotation of 90 degrees on the y-axis will allow you to create a wall in the middle of the stage, and using your x, you can move it left or right to place it on either end of the stage. And then z-axis will make a plane spin around the center of the comp like a pinwheel. If you combine the rotations, it's going to affect the outcome in difficult ways to describe. So try to use just one axis of rotation when possible. You can use the orientation transform to set the original position of an object in space, but don't keyframe orientation. So here's a depiction of what I'm talking about with the different axes. The x-axis, you can rotate it and see that little blue circle with the dotted line in the arrow. So you can rotate it so it looks like it's a ceiling. You could walk underneath that ceiling, right? And then the green axis, the Y rotation, you can rotate it so it looks like a wall. It looks like that's a partition wall. You can walk up to it and hit it. And then the Z-axis, the blue arrow axis, you can rotate it around and it's just facing you and just rotating around like a pinwheel. So this is what you would do if you want to have something spinning around like, daisies spinning or something that you would be able to see from the front. So 3D layers allow you to cast shadows that are calculated from the direction of the source of light as it passes the position and shape of the 3D objects in the path of the light rays. But the shadows can only be cast if the 3D layers have the correct material settings. And the light is a spot, point, or parallel type with cast shadows enabled. So if you're having problems with shadows showing up, you've got to check several different things. You can't just check one thing. So on the foreground layers, you want to make sure that you have 3D turned on and make sure that you have enabled shadows under the material options for that layer. For the background layer, then check to see that you have 3D turned on and enable accept shadows under the material options. And then finally, you want to make sure you have a light that has the shadows enabled. You can also create a shadow catcher layer by choosing accept shadows only for a layer positioned in Z space behind another 3D layer casting a shadow, but that's only true if you're in 3D Classic or Ray Traced. You can't make a shadow catcher layer in Cinema 4D renderer. Text animators. per character 3D allows the transformation of individual letters in X, Y, and Z space. And remember, we did have that happen in one of our tutorials. And if you want to look up the help, I've got the address here. Text animators will animate position, rotation, opacity, and some other transforms. They're the basis of the typewriter effect and the other text animation presets. They can be saved as your own animation presets. Text animators also allow you to use wiggle, bloat, and other properties effects. They'll also let you animate the letter spacing or some other things that relate to the color. Camera settings and focal length. Now, a 35mm lens is a common wide-angle lens, a common fisheye. 50mm is the normal lens that you usually have. That's what you would usually use on a camera to make it look like regular life, a regular view. And that's what you usually see through, say, your phone camera. And the 135mm is a common telephoto lens, and that's the kind of visual you would see if you were watching like a football game on TV. They usually use a telephoto lens so you can see everything really very close up, get a lot of detail even if something's further away. A camera orbit null. A camera orbit null is an empty layer that is the parent of the camera, and it's the parent of the camera layer because you can then control the position and rotation without changing the camera transforms, which may be difficult to control. But if you do it using the null, if something goes awry, you can just delete the null and the camera goes back to where it originally was, and it's not a problem. If you've been moving all the settings for the camera, you may not be able to get it back to where it was. It would be very confusing. But with the null, you can just delete it and boom, it's back. And you can change the null settings any way you want to and control what the camera is doing, and it's a lot easier. So keyframe types and interpolation. Remember when we were doing all of that work on ease in, ease out, different types of timing when you're putting in keyframes to make them line up with things and have a really a motion that seems reasonable and normal, and it would be related to real life. So linear interpolation is the default. It creates a uniform rate of change between the keyframes. Hold keyframes do just that. They hold the object until another keyframe appears, and then the object will jump. A roving keyframe keeps the spacing proportionally constant between keyframes. So you have the beginning and the last keyframe you can't make roving, but the ones in between. And then if you grab, say, the end and move it out, so move it further away in the timeline, all the other keyframes move and follow along proportionally. Easy ease keyframes have Bezier handles, and they let you adjust the rate of change as the object nears the keyframe. So easy ease is also another word they use for Bezier. So the Bezier looks exactly like that, the icon. Easy ease is really just a very special type of Bezier keyframe. Ease in keyframes. So you ease in like trains in a train station and slow down to a stop. So you're going fast and slow down as you come in. You ease out of the station and speed up as you leave. So you start out slow and speed up. And the reason it's important to remember this for After Effects is because After Effects actually has reversed what ease in and ease out the terms are used for. In other programs, it's the exact opposite. So remember that you're easing into the train station, you're easing out of the train station. It's the only way to really remember it correctly for After Effects. Some options that are available in the Cinema 4D renderer. When you select the Cinema 4D renderer, you will see this. This is the composition settings, and it shows you that You can have enabled extruded and beveled text and shapes, yes. Reflections, yes. Curved footage layers, yes. Material overrides on text shape, bevels, and sides. And basically, that's something that you got to figure out what they mean by that. If you put in a stroke around a text font, it will treat it as a bevel. So you got to figure out how that works when you're playing around with material options. And then environment layers in reflections only. So you only see it in a reflection when you make it an environment layer. In the 3D ray trace, if you make something in an environment layer, it appears in a reflection and it appears as a world around you. So that is different. Disabled, blending modes don't work. Track mattes don't work. Layer styles don't work. Masks and effects on continuously rasterized layers, text and shape layers, and collapsed 3D pre-composition layers. I believe this is why we lost transparency when we were trying to use comps inside of another comp. So you have to actually take everything out of that inside comp and put it in the outside comp, and it's just complicated. So if you're working with something and it doesn't have 3D, you have to move it back into the other comp. But if you don't want to do that, I'm going to be perfectly happy to see it be 3D classic. Preserve underlying transparency. That's another reason perhaps why we had problems with the comps. Light transmission, so you don't have light going through things. You can't have adjustment lights. You can't have transparency and index of refraction. This was one of the nice things about the 3D ray tracing, that you could make things look like they're different types of crystals because you could change the way that light went through it, but you can't do that with the Cinema 4D. Except shadows only. You can't have a shadow catcher layer because you can't have except shadows only on for a layer. Motion blur, so you can't make things look like they're blurring as they move. And then camera depth of field. So anything that involves changing the amount of focus, it doesn't work. So that's what's different about Cinema 4D. So those are the things that you have to realize. There are some positive, good things that will actually render faster, but then you have the trade-off is you can't have some of these other really nifty, keen things you could get with the 3D ray trace. The compression and codecs. Compression is the way that you reduce the size of your file by keeping track of information but not saving each pixel or bit of information separately as the program normally would. And this is like JPEGs. You don't have as many colors as you would in the original file, but it makes it much smaller. So the video quality and the video codec, we were using H.264, and like I say, 40 to 50% for the video quality is probably fine. If you wanted to come up with a really, really nice finished looking file that you want to use in your portfolio, you might go ahead and save it at a higher video setting. You may even save it without compression at all, but it will take a long time to render and it will take up a great deal of space. So this is what we are using for our codec, H.264. Camera moves. The point of view. So a change to what is visible by moving the camera or adjusting focal length, angle of lens. So a POV is a scene from the point of view of a character, a point of view or POV shot. Wide angle, a large overall view of the scene, an establishing shot to orient the viewer. A close-up. Close-up is an area of detail within a larger picture. Zoom in, zoom out, continuous advance or retreat of the camera to the subject. And then panning is the horizontal, vertical, or diagonal scan of the subject by rotating the camera itself. Remember the meanings of the words frame. A frame is a single image that is part of a scene, one image on screen at a moment of time. A keyframe is a frame showing an important change in position or appearance, used as a guide for subsequent action, used in storyboards to tell the story, showing the beginning or end of a move. And then a storyboard is a visual outline of an animation or movie using keyframes to describe the action, contains notes about dialogue, camera moves, and editing. Okay? So it's important to know how to do a good, clean, easily understood storyboard, because this is something that a lot of employers are looking for, the ability to express your information and to share your ideas so that people can work with you on something that needs collaboration. So computer terms and definitions, remember that a bit is one binary digit, 0 or 1, that's held in a memory cell in a computer. It's the smallest piece of information with 2 possible states. And then a byte is 8 bits of information. Raster or bitmap graphics, your image is composed of individual pixels on a two-dimensional grid. And vector, object-oriented graphics, mathematical formulas are used to describe the shapes in the file, like a circle defined by its radius, a triangle defined by proportions and length of sides. Fonts are scaled without losing definition and appear the same at any resolution. So you see that the font on the left is a vector image. The font on the right is a raster graphic. RGB color is the additive color system model that is used in film, video, and web. Light is emitted from the source, so a wider gamut of color is available. You get more colors when you're adding more. CMYK color is a subtractive color system model. It's used for print. The ink on the surface absorbs light, so fewer colors are available. So some computer terms and definitions to remember. A pixel is a portmanteau word, meaning it's like put together like a suitcase. You've got one half, another half, and a hinge in the middle. Close it together. It's a portmanteau made from the word picture element and refers to a dot of light on screen that makes up the picture. Good luck on your exams. This quiz has 25 questions that are multiple choice and is based on the information in this review session. You will also complete an in-class project using provided files and information. Project for animation and tutorials, these are due. So you've got the 3D text, 3D more, 3D lighting, 3D camera, the poor character 3D text, and actually that should be 3D Cinema 4D. Last name, first initial, Project 04, either MOV or MP4. This is your animated 3D identity project. So good luck. I hope everything works for you guys.